This one, in this approach, we are going to take the algebraic approach to graphing the trinomials, or graphing the parabolas. And you just have to remember the process, the order. And the axis of symmetry, use the formula x equals negative b over 2 times a. And then you just substitute the values in. So since 4 is already negative, it's going to become positive 4 over 2. And so we get the equation x equals 2. And we will graph that in a second. To find the vertex, okay, we know that the vertex is going to have 2 because that's my axis of symmetry. And then f of 2, and if you look back in your notes, we kind of talk about that a little bit more formally. And so I'm going to find f of 2. And once again, I picked 2 because that's what I found for my axis of symmetry. And f of 2 is going to equal 2 squared minus 4 times 2 minus 12. And when you work this out, you get 4 minus 8 minus 12, and that equals 16. Okay, so my vertex is going to be 2, 16. My x-intercepts, you want to, I'm sorry, this is negative 16. My x-intercepts you want to factor, okay? Because you set y equal to 0 because you're always thinking, okay, well I have x and then 0. So at the x-intercept, y is always 0. I have 0 equals the original problem, which is x squared minus 4x minus 12. And then you just factor this however you need to, which in this case is x minus 6 times x plus 2. So that means you have an intercept at x equals negative, or 6 and x equals negative 2. And you write those as points. And then my y-intercept is 0, negative 12. And the reason I know that so quickly is because the y-intercept is always 0 and the c value. And when I look up at the c value, it is negative 12. And we talked about in class why that is. If you substitute 0 in for x, it's always going to work out that it's the c value. So since these numbers are kind of big, my vertex and my y-intercept, I'm going to go ahead and count by 2's on this one. So I have negative 2, negative 4, negative 6, negative 8, negative 10, and I know you kind of can't see, but just know I'm counting by 2's. You should probably change yours that way. And so this I'm still going to count by 1's. 1, 2. So at 2, negative 10, 12, 14, 16. Here's negative 16. Okay. And then I have my y-intercept at 0, negative 12, which would be right here. Okay, and my axis of symmetry is a dotted line that goes through x equals 2. So here's my axis of symmetry, x equals 2. And my vertex is at 2, negative 16. I found that. Now I have to plot my x-intercept, which is 6, 0. So 1, 2, 3, 4, 5, 6. Remember, I'm counting by 1's. And negative 2, 0. And then I have my y-intercept at 0, negative 12. And we want to find 5 points. I have 1, 2, 3, 4. And the way you get your 5th one, it's going to be over here somewhere. And you know that this is the axis of symmetry. So since it's 2 units away, it's going to be 2 units away on this side. And everything should be symmetrical. And it is. So I just connect all these points. And this is how you graph it. Algebraically, using the algebraic approach, you just work it out, find your 5 points, and graph it out.